Hi,
Hey, how's it going?
I'm fine. How are you?
I'm
Yes,
good.
now I can hear you.
Yeah, great.
So I would like to ask you to introduce yourself to the viewers. Maybe not everyone is familiar with you.
Sure. I'm Colby Fayock. I'm a UX and front-end engineer at Element 84 here in the United States. The team that I work for specializes in bringing data to the cloud, specifically remote sensing and health data. And then I put the UIs in front of that. So I'll be kind of explaining how maps can be impactful from that regard and a little bit about how we can all build those kind of maps. So I'm excited to be here. Thank you all for having me.
I think without further ado, I'm just going to play the talk now. Okay?
Sounds great. Hey Accento, today I'm going to talk about maps. We're going to talk about the impact they can have on the world and how you can get started with a little bit of JavaScript. So who am I? I'm Colby Fayock. I'm the one hugging BB-8 and Kylo Ren over there. I work on the UX and front-end side of things at Element 84. You can find me pretty much anywhere by just Googling my name, as I'm the only one in the world. Looking at this first slide, it's a screenshot of Google Maps in downtown Alexandria, Virginia, here in the United States. This is Element 84's HQ. We're all probably pretty familiar with Google Maps or Apple Maps. They provide us with a lot of features that we use every day, like here we can check out some points of interest nearby, we can find where we can grab a quick cup of coffee, we can find the best sushi, which is Momo if you're in the area, or just look for some pictures nearby. This next screenshot is of public transit directions. It's showing the metro I would take to get from my last apartment to work. My wife and I share one car, so when I didn't have it, I was able to get a good idea of how long it would take to get downtown. This next one shows some driving directions. This is the route I would take to get from my mom's house to where I grew up. The time here is a little optimistic though. It never actually took under 4 hours to get there with traffic. So how many of you like to travel? As much as we'd probably all love to be in another country every other month, that's usually not feasible, especially now. So my wife likes to take virtual vacations around the world, which is also a little bit better for the budget, but Google Maps helps her easily travel around and check things out. Here we're getting a good look at the Great Pyramid of Giza. We can see an overhead view from above and get an idea of what the area actually looks like. The cool thing about this though is we can get the close-up look with Street View. We can actually get an idea of the scale of this structure. It's huge, and we can get an idea of how big it really is. When I was talking to my wife about this, she was in the middle of one of her journeys. She wandered to a place called the Valley of Geysers, which is located in Russia on the Kamchatka Peninsula. Turns out that this geyser field has the second largest concentration of geysers in the world. It's just wild to me that we can get a picture of this place. And that's all because someone took the time to take a picture of this remote area. This particular picture was from a local guide, so really any of us can do this. The neat thing is that we can check this kind of place out, even if we'll never have the opportunity to go. It's obviously not the real thing, but we're still able to get a glimpse of remote places all around the world. So where do we actually get the data to build out these features? First, you have an obvious one, scientists and analysts. This is just a stock photo I found on GIS University, but they're constantly hard at work collecting and processing data. I have to hope that they always look this happy though. We also have technology. Thanks to the cars and the people that build Street View, we can get a close-up look at the pyramids, and we can also get some fun Easter eggs along the way. This also includes a ton of people all over the world, like I showed in Russia. There are local guides all over contributing pictures and data. Did I mention there were Easter eggs? Thanks, Tokyo. There are a ton of these like this all over the internet. But then we have satellites. There are a bunch of different types. Some collect imagery, some collect more in a data format, but they help produce the assets we use to create our maps. A good example of this is Cryosat from ESA. It uses its onboard instruments to measure changes in ice thickness. It can measure changes as accurate as 0.7 centimeters per year. The example on the right is showing Antarctica mapped out in 3D using the data it collected. Another example is NASA's MODIS Terra. Using its image sensors, it covers every point on the Earth every 1 to 2 days. It covers large-scale global dynamics like cloud coverage, ocean processes, and changes in atmosphere. The shot on the right is a photo over Lake Erie in the US. NASA alone is working on all the ones you see here. They published this image to show the state of missions operated by their Earth team. It shows satellites in orbit now and out until 2023. But NASA and ESA aren't alone here. There's thousands of satellites like those flying over us right now. Some of them aren't even working, but a lot of them are collecting images and data about our planet. These satellites are also cool from a consumer point of view. NASA and other teams put pictures up on Instagram for our daily dose from above. At the top, you see the International Space Station, which I know it's not a satellite, but it shows the Earth at night. The bottom is from Daily Overview. It gives us a look at Lake Natron in Tanzania, which is just mind-blowing. Then on the right, we have this gorgeous look from NASA Earth, a picture of Merguiat Archipelago, which is on the border of Burma and Thailand. It's awesome to be able to see these kind of pictures right in your Instagram feed. But switching back to maps for a second, this is just another look at downtown Alexandria. But behind that, it's OpenStreetmap. OSM is an open source project. It maintains a huge set of metadata that includes the attributes and the properties that define specific geographic areas. It allows mappers all over the world to contribute. So with their tooling, anyone can identify points of interest or update features. So with our powers combined, this means that another source of the data is you. But millions of people all over the world have mapped with OSM. There's meetups and communities all over. Others just work alone as individuals, but thousands of people work on this every single day. You also see big companies who use or contribute back to OSM, like Apple uses it for regions where commercial data isn't available. Lyft also contributes back with their work. They're all adding points of interest and drawing the streets. It's more than just learning about what's in the US or in Germany, but third world countries all over the world. This is incredibly helpful from a humanitarian aid perspective. Here we can see an identified refugee camp on the border of South Sudan and Ethiopia. A lot of times, people in these areas might not know where they can be safe, but OSM allows people to identify these features that help others survive. So where am I going with this? The point I'm trying to make is that these maps are for more than just driving directions. Maps are literally giving people tools to save the world. There's tons of research going on in many different areas, from climate change to agriculture. By taking collected data and applying it to a map, we're providing another visualization medium for scientists that can actually make a difference in people's lives. Some examples that you can find online are services like NASA's Worldview. Here we can see Tropical Cyclone Idai, which was one of the worst cyclones on record to affect Africa in the southern hemisphere. It affected close to 2.2 million people in eastern Africa. It's insane to see the scale of this storm. Another is NASA's Firm service. It allows you to see active fires all over the world. Here we can see a cutout of the Australian bushfire wildfires. We can see the number of active fires in each area. There were devastating losses from this disaster, but tools like this help teams manage resources for determining how to help in these scenarios. And for something pretty current, which is why we're all online instead of in Karlsruhe, we can take a look at this map from Johns Hopkins University. It shows the number of coronavirus cases around the world. Showing the visualizations on the map help people identify the larger areas of impact. Similarly, this map from NextStrain shows the evolution and spread of the virus. If you visit this page, you can actually play an animation that shows how the virus spread. These types of tools are incredibly helpful for anyone in the science community that's trying to study and understand more about the virus. But on a lighter note, people are also doing some fun things with maps. Like here, radio.com, they have a map that lets you select a country and a time period, so I can listen to music from Germany in the 50s or Brazilian music from the 30s. But there are a ton of well-known teams that are doing great work trying to help. These are just some of the ones from the United States. We have USGS helping to map out earthquakes. We have USDA monitoring food access. And they're not just monitoring the US, they're monitoring all around the world. They're all helping work towards providing more information to people who can actually make a difference, which is directly translating to lives saved. So how does all this stuff actually work? It definitely seems intimidating. There's a lot of information there, but getting started probably isn't as bad as you think, so let's break it down a little bit. Mapping applications look like your standard JAMstack app. For those unfamiliar, JAMstack sites are JavaScript APIs and markup. It's pretty much a static HTML website, but utilizing JavaScript in the browser to make any requests to your APIs that would provide dynamic data. It's not necessarily a new idea, but the architecture's got a cool name, which comes with some cool references. The JAMstack concept is pretty much what you're working with out of the box with maps. First, you have the JavaScript that makes the map and libraries that load the map run. Layered on top of that are your APIs, which for maps looks like your underlying imagery and anything you put on top. That compiles down to your markup, which the output is your standard HTML. That ultimately gets served to the person who's using the app. So let's start at the top with JavaScript. We're going to take a look at Leaflet. Though it's not the only one, it's the most popular mapping library available right now. Here we have a simple example of a map that we get from Leaflet's homepage. It's a pretty basic map. On top we have a simple marker and a pop-up, but behind that we're using OpenStreetmaps. That's providing our base map layer. So how do we get there? Believe it or not, this small snippet is all it takes, so let's break it down. From the top, we create a map instance. That map instance takes an ID, which is the ID of the div that we're mounting on, kind of like the same concept of when you would mount for React. Next, we set the view of the map using longitude and latitude, and we also set the zoom level that allows us to determine how far in we're zoomed to the map. Next, we describe the layer that we want to add to the map. This part is called the tile layer. I'll go over tile layers in a little bit, but we set up a new tile layer instance using an endpoint URL. We also provide an attribution to give the service credit. So this will give us the base of the map, but how do we get that marker? This last snippet creates a marker. Using a leaflet marker instance, we set the position of where we want the marker to be using the latitude and longitude again. Then we bind a pop-up to the marker with some simple text, and we continue to open it up in its place. And after that, we have our map. All right, so if you're anything like me, you like to build your applications in React. Luckily, we have React Leaflet, which is a library that takes Leaflet and builds out native React components to help quickly build maps. Here we have the same example that's shown on the React Leaflet homepage. If you notice, it's the same map as we saw before, but now it's built with React components. Breaking this down again, we have a map component that wraps everything. We set our latitude and longitude using the center prop. We set our zoom with the zoom prop. Inside our map component, we have a tile layer component. There we add our endpoint and an attribution. Then we add a marker component. We set the coordinates with the position prop, and inside that we include a pop-up component, which we can then nest with our simple text. And again, we have our basic map example. And if you're not a React fan, there are definitely some other flavors of Leaflet available. Angular and Vue both have libraries to help you get started. Unfortunately, I couldn't find a logo with an Angular and Leaflet mashup though, but it's okay. But while React provides a good base to get started, the real magic is working directly with the Leaflet API. The way Leaflet works is by attaching itself to the browser window. This is probably less common than it used to be, but once we have our component mounted, we have access to all of the Leaflet's APIs, where we can create maps not of this world, like the example you see here. But that kind of thing isn't without its ups and downs when trying to mix it with React. React has its own internals to maintain state. But once you start building complex solutions, this can start to get out of sync with the map if you're not careful. The solution we've taken is to start with a React foundation, but build on top of it with the Leaflet APIs. This allows you to easily construct our map, but then perform complex operations with the data we want to display. On top of all of that, there are a ton of plugins that layer on top of Leaflet that makes it easier to do hard things. In this screenshot, we see Leaflet Anti-Meridian. The challenging thing about maps is the Earth is actually round. So when trying to represent this in a 2D format, your coordinates map to a single area. What ends up happening is like the top, where the lines kind of look like they're going back and forth across the map. So to fix this, we can use a little bit of math and process the location data, or we can use a plugin to take out the hard work and know we're getting it right. A more visual example is Leaflet Terminator. It lets you easily overlay day and night regions on the map. It's a nice way to easily visually identify time references. All right, so getting to that point isn't too bad, but let's talk about the data that actually goes into building the map. When dealing with maps, I like to think of a poorly drawn layer cake. The base map is the actual cake, then you have your overlays as your icing, and some data sprinkled on top. Your base map typically looks something like OpenStreetmap's or Modus Terra as we saw before. Your overlays could be anything like a small sample of high-res imagery or heat maps to visualize data. On top of that, your data can literally be anything such as active fires or evacuation zones. Starting to dig a little bit further in with the base map though, this is essentially the map imagery you have available that covers the entire globe. This will be the foundation of your map. The map image layers are called tile layers, which are composed of a bunch of small tile images that make up one large image. You can see on the top we have our tile endpoint. There are a few properties that get programmatically swapped out, like the date, zoom, and the X and Y axis. The nice thing about this endpoint scheme is it's common, so we can just as easily swap out an endpoint for OpenStreetmap, for instance. The reason this gets broken up into smaller images, though, is you don't want people to have pull down those huge image files, which the entirety of the map could be possibly over 1 GB in size. But realistically, the person using your map might only use a fraction of that image. Overlays are very similar to your base map, but a lot of times they don't have nearly as much imagery available, which is why they're called overlays. This could be if you have high-resolution imagery for only a little part of the map, or if you want to show a different kind of image over your base map, such as a heat map. Here we have an image overlay of the 2020 population density on top of OpenStreetmap. We're showing Europe, where on the right you can see Karlsruhe, and you can see Paris and London on the left. This is another example of some of the imagery NASA provides. And then we generally have data. Using shapes, we can visualize this data any way we really want. Here we're providing individual points on the map for each active fire. But you can also use lines, circles, polygons. Here we can see the fire boundary for those same wildfires on top of OSM. The points are really helpful for us to see the actual active fires, but seeing this boundary can be easier to comprehend the actual area of danger. The point, though, is there really aren't any requirements for visualizing the data, but there are standard data formats that you can interface with Leaflet. Though there are a few, I found that GeoJSON is the most common with my work so far. It's really just a JSON document that has a particular schema. The site I'm showing here is geojson.io, which allows you to draw on the map and get the GeoJSON. You can see here that we have a simple square. It creates a feature with a geometry type of polygon. Then we have our 5 coordinates, which represents the line that's drawn to make our 4 corners from going open back to close. Now, some of the data is free, some of it's not. NASA provides a ton of public data and tile endpoints. It makes it really easy to get started in a kind of plug-and-play way. I showed you a few of those already, like the population heat map and our base map, but others such as Digital Globe provide open access to limited data. They have an open data program that gives access to imagery for disaster areas. This helps immensely for teams trying to put together solutions to help those fighting the disasters. But the rest of it would be a premium product that you would have to pay for. But APIs can range from simple to extremely complicated. Most of the time, if you're building commercial solutions, you would probably want to roll out your own. This way you can protect your data and have more control over what you're working with. And there are tools to help you do that. Stack, for instance, is an open source spec that helps making geospatial data searchable. There's an API that's also open source that makes it easy to make those searches. But say you wanted to make that data private. Since this is client-side, we can require authentication on each request, which opens the door for data manipulation, where you might want to do some on-the-fly processing based on user controls. You can end up with some really powerful solutions. All right, so once we have our map and we have our data on top, we need to compile it down and serve it to the browser. This is actually the shortest step of the group. Compiling the app is pretty much the same as you would expect for anything else built on a Webpack-based app. You can use your favorite tool like Create React App or Gatsby, and those compile down to a static site, which outputs HTML, CSS, and JavaScript. Once you have the compiled version, you can serve it wherever you want. At that point, it's really just object storage. So whether you want to put it in a bucket on S3 or use Azure's new static tool, you really have a lot of options. So what can we build with this? We've been working hard at Element 84, trying to work with first responders in disaster scenarios to come up with a really to use UI. The goal is that we can get the UI to a point where they don't have to think hard to get the information that they want from the map. This is a picture first responder Trevor Skaggs took as he was up against the campfire wildfires in California. There are many natural disasters like this that unfortunately take place every year. It's intense and it impacts people's lives, and we want to try and help. We want to be able to put tools in people's hands that can actually make a difference. Those tools can help them fight current disasters and be more prepared for the next. We call this Film Drop DR. This is showing the east coast of Australia. I'm sure most of us are familiar with the bushfire wildfires that devastated their east coast. We can plug and play really any data source and provide an easy way to visualize it. Here we're showing some of the active fires on top of satellite imagery. The hope here is that whether someone wants to look at the active fires or the boundary, they don't have to fumble around with a bunch of advanced settings to get there. After talking with some of the people who are actually working in the field, like Trevor, we determined that we need to get this thing to a point where an operator can understand it in less than 15 minutes. As much as some of the other UIs available have really great granular controls, there's just not enough time to try to explain that or simply try to figure it out on your own. And with a simple toggle, we can get a completely different perspective of how a fire is impacting our area. This particular shot is from the California campfire wildfires. We can see the active fire points and boundary over satellite imagery, and we can also see high-resolution imagery and the active fires over street maps. Another feature we added is the ability to add data points to the map. If someone reported a missing person, they can easily add this data point to the map and sync it up to the cloud for others to see. The cool thing about this is we can store this locally in the browser. That way, if the person is using it doesn't have network connectivity, they can sync it up later when they do. We also want to provide the ability for people to collect in-situ data and immediately make it available. Someone with a drone can map out their area, upload it to the computer, and sync it with this app to make available as a new layer. That can provide some really powerful up-to-date imagery to better understand your surroundings. This imagery is actually from a coworker of mine who flew his drone up over Lake Lansing in Michigan. And FilmDrop also gets a little bit more interesting on the data side. Not to go down a rabbit hole, but we're building this to be able to upload data directly to an AWS Snowball Edge, which is that gray box you see with the laptop sitting on. It's basically a cloud in the box, and this gives people out in the field another level of processing powers and capabilities that they just didn't have before. So what makes this impactful? Well, the hope is that we can help first responders get the information they need to be more productive and efficient in the field. That could directly equate to more lives saved in many scenarios. So realistically, imagine someone in an area without cell service, like a big forest. They can fly a drone, upload that to the Snowball Edge, and process that to visualize on a map. This can help show things like what areas are impacted by a fire that are no longer safe to go to. That can immediately help save someone's life. Another thing we're working on is an app with one of our customers in the commercial satellite space. So I'm sure we can all agree that space is pretty cool, and the idea that these machines are floating around in space collecting data is just mind-blowing. But how do we collect that data and make it available in a format that's easy to consume? We're working closely with Capella Space. We're helping to provide scientists an easy way to look up and analyze the data that Capella has collected with their satellites. Here we're showing a search of Rotterdam. We can see all the imagery they have available at the time. Once you select one of the results from search, you can get a closer look and actually overlay the image on the map. This also comes with a big bucket of metadata. We only get a glimpse of that here, but that's typically more useful for people who are working closely with this type of data every single day. And if Capella doesn't already have the imagery they want, we provide an interface that lets them actually task their satellites in real time. Once Capella receives this request, they'll utilize the open and close date to capture imagery of the requested area the next time their satellites pass over that area of interest. Once Capella's satellite successfully captures that imagery, we run it through a processing pipeline using AWS Cloud Services as part of our FilmDrop solution. Here we use S3 buckets for storage. We allow Capella to set up some custom lambdas for running their science code on the data, and then the output is a metadata repository that we can put a search API on top, like Stack. Once they find that data with a search or a new task, they can proceed to order it. The order provides access to pretty much all the assets. That's usually the high-resolution imagery and a dump of the metadata. We're pretty excited for Capella as they're set to launch their new Sequoia satellites this year. These satellites will collect SAR imagery, synthetic aperture radar. They'll allow Capella to collect at a 0.5 meter range through cloud coverage and even at night. The UI that I just showed you will allow their customers to task this satellite to collect imagery in the areas that they're interested in. So again, what makes this impactful? Well, we're providing a way for scientists to easily discover and analyze data from their satellites. This gives them more tools and information to make better decisions that could impact the people on this planet. And we're in the middle of summer, so how about a road trip? Of course, we can have a little fun with this too. I put together a simple demo that tracks a summer road trip on the east coast of the United States. This is actually a road trip I took with my wife in 2015. Ignore the straight line out to Vegas, we actually flew for that part of the trip, but it allows us to simply get a look at all the locations that we want to stop at throughout the United States. The cool thing is we can select one of these points and get a little itinerary with a picture from when we were there. Now, how do I put this together? So the first thing I did was start collecting the locations I wanted to work with and put them in a structured data format. Once I had that, I spun up the base of the app using a Gatsby starter I created with Leaflet. I'll get to that in a little bit here, but for now, it's going to be a little bit of hand waving. With those locations, I needed to take the structured data and translate it into something our mapping library would understand. This particular format is GeoJSON, which I was able to create by mapping over the locations and making the shape groups. I actually needed to do this 2 times, once in this example where I created the different latitude and longitude points, but also in a separate instance where I put together groups of 2 so that I can create a point with a line. After we have our data in the desired formats, we can take those raw GeoJSON data sets and we can plug them into a Leaflet GeoJSON instance and simply apply them to the map. You'll also notice here that I'm getting the bounds of the GeoJSON, which is essentially the area the GeoJSON takes up on the map. Once I have those bounds, I tell the map to view its current view to those bounds. So how about those tooltips? On the last slide, we showed one of the GeoJSON sets with a custom option point to layer, which I've highlighted here on the right. What this does is allow us to pass in a function where we can modify the layer being created in Leaflet from our data. What we're doing is for each layer that gets created, or a point, we create a new marker. Within that marker, we bind a pop-up to it, similar to what we saw in our basic intro earlier. Within that, we create some custom HTML in string form that allows us to set the custom content of that pop-up. With all of that, we have our map with some custom tooltip pop-ups. Not too bad, right? But we could even extend this if we wanted to. We could sync this to dynamically pull from our Instagram and show a gallery of images during our trip. We can use today's date and highlight where on our trip we're at for that particular day. We can even add a timeline where we can play back the road trip. But to get there, the starter takes out a lot of the need to bootstrap the app, so we can get productive right away by playing with the data. And if you're curious or interested in getting your hands dirty, the source code for this is up on my GitHub, which I'll post to Twitter later. That's not a hint to follow me or anything, but I'll also include it in my talk notes. And for the last time, what makes this impactful? For me, it was just fun to build. I love road trips. It's fun to take some normal event and make it a little bit more interactive to share with a map. Now, when I talk about we, I really mean all of us. I want to drive home the point that any of us can do this. The tools that we have available make this accessible for anyone to build with. So as I mentioned before, I started the app demo with a starter. To help get people productive more quickly, I put together a Gatsby starter for Leaflet. We can very quickly spin up a mapping app with little fuss and immediately become productive. Using the Gatsby CLI, you create a new project with a Git address. This grabs the project and it installs all the npm dependencies. Then you run yarn or npm develop, and this starts your local server. And then we have our mapping app. It's simple. I've been trying to add features little by little, but it's a good foundation to get started with mapping in a React app. And as a bonus, the summer road trip demo can be used as a Gatsby starter. Similar to the Leaflet one, you can instantly spin up a new road trip app just by using the Gatsby CLI like the other starter. I also wrote a tutorial that actually walks you through setting up one for yourself. It goes step by step through the functionality with split out commits just for reference. I'll also include that link with all my other resources. You can also deploy it straight to Netlify if you have an account. That makes it really easy to spin up fast. And just to note, this works for anywhere in the world. It's not just the US. Just remember to update the photos. I also have a few other guides available today, like creating a travel bucket list or creating a stats dashboard for the COVID-19 pandemic. I'll also include those links with all my resources. And if you're interested in getting involved, there's a huge community out there waiting for you. You can find State of the Map conferences all over the world. They have a huge community of people working with maps. The interests there range from people collecting map data and people using the data. I was lucky to go to one 2 years ago in Michigan as an attendee. It's awesome to see how passionate people are about the technology, and the stories will both break your heart and inspire you to do more. If you want to get involved from an actual mapping perspective, OpenStreetmap gives you tools to get started. This screenshot is showing the roads and locations around the Südwerk in Karlsruhe. You can see on the left some of the metadata for the location. But we can go into edit mode and make changes. For instance, we can click into the street. We can see that the speed limit is 30 kilometers per hour and the surface type is asphalt. If something's wrong with this, we can make changes to help keep things current. They also have a nice guided tour. It walks you through each of the tools to teach you how you might make changes on the map. And they also have a vast wiki to help you get a good idea of what's going on. You can be a part of a huge community of mappers working every day to fix and keep it updated. I found this particular photo on the OpenStreetmap Facebook community, which I just thought was really cool to see. So did I inspire you to learn a little bit more about maps? Well, if I did, keep an eye out on my Twitter and on Egghead. I'll be giving a workshop where I'll teach you how to create your own mapping app. We'll start with a Gatsby app and we'll learn how to manually walk through adding a map with your data. Details will be announced soon, but in the meantime, I have a bunch of lessons already on Egghead that you can walk through for free today. And that's it. Thanks. Feel free to reach out to me for more questions or if you want to chat about maps.
All right, so now we have time for some questions. There is a question already. Samuel Sandro asked, I've always wondered, how do you pass from an image from a satellite to an image on the map? For example, a WMS service. I mean, orientation, positioning, rotation. Is this meta info provided to the image header, or the image is not enough? We need extra parameters for orientation and positioning. Any tool resource which helps with that?
Sure. So I don't know the exact specifics about how it gets down through the entire pipeline, but pretty much when the imagery is captured from the satellite, it's definitely coordinated with metadata that provides things like positioning and such. But when it actually comes down to the application where we use it in the browser, Tools like Leaflet allow us to use different projections, which, depending on what projection you're using, can do different, can lay out the imagery differently. So for instance, one projection might be a flat 2D map. One might have the curvature of the Earth a little bit differently, given the Earth is round. So being able to coordinate those different projections, you'll need to be able to, it depends on how those images are layered as tiles on the map. I can try to find more resources specifically about that entire process, but that's a little bit deeper than the end of it that I work in personally.
You talked about creating a map about the Australian wildfires, and I've been wondering, how do you make a map? Is it easy to make a map responsive? Because you would think that most people who provide your data, like that's another question. So let's maybe talk about that first. How do you get data about these wildfires? Because I would think wildfires like spread rather quickly, so you would need to update the map rather quickly. How do you get that data?
So it definitely depends on the source, and the source depends on how frequently you're going to get updates. But one of the services we use is from NASA, their VIRS, I think I'm pronouncing it, VIRS, where they actually provide the active fire data. They even have a map itself, which I kind of showed throughout the talk, but really we're kind of dependent on their data. So I'm not entirely sure what their frequency of updates are, but it's relatively frequent because scientists are actually using that data in real time to try to help these situations. So it's got to be somewhat current.
Okay, and related to this, how hard or easy is it to create a responsive map?
And when you say responsive, do you mean like a browser?
Yeah, because I imagine most people who you want to reach with this map are in the field, so to say. So they are mostly using mobile phones or smaller devices.
Yeah, luckily it's not too bad. The one thing with Leaflet that you need to keep in mind is that you need to have fixed dimensions, but that could just as easily be using CSS that makes the container fit the entire screen. So if you set your CSS to just take up the entire screen, that'll scale along with the device and work just great. Leaflet even has touch-friendly capabilities in it, so it kind of works out of the box as long as the map container scales with the device size.
You talked about a lot of different technologies like JAMstack or Gatsby or OpenMap, Leaflet, a lot of things. How would you, where to start if someone is entirely new to this whole thing?
So I'm a little biased. I have a Gatsby starter that I put together. It just makes it really easy. If you're not familiar with Gatsby, it's a website framework where they have what's called starters, where you run a command line tool and it pulls down a repository and creates a React application for you. So it makes it really easy to instantly spin up a React app if you're already familiar with React. So if you want to use that, I'm going to include that link as part of my talk notes if you want to check it out. Otherwise, if you're just using a basic React site, the React Leaflet homepage makes it, they have a lot of documentation that makes it easy, as well as just the native Leaflet if you're not using React, where you can include the library as a from a CDN and then kind of immediately get started with a few different commands, like the intro that I walked through.
At this point, I really hope someone would ask the question in chat. Okay, so you mentioned Easter eggs in Google Maps and maps in general. Do you have a favorite one?
I don't know. I really like the scuba gear one. It's really funny watching the people try to walk down this. Well, you can't actually watch them walk down the street, but seeing the picture of them in the scuba gear behind the Google Streets car is pretty amusing.
We found one Easter egg which was in Google Maps, the travel route planner. How do you say this? if you planned a route between Japan and South Korea, it told you to go down this route and another. And once you reach the sea, it said, "Okay, and now take a jet ski through the Pacific Ocean."
That's awesome. Yeah,
and
there
the
are
other
always
one,
little fun things.
And the other one was if you went from Japan to the United States, it told you just take a kayak.
That's amazing. I'm very curious to see if anybody actually took a kayak.
How familiar are you with NASA's API?
Just kind of a little bit familiar. I don't work with that project as much, but my other team members are the ones who work more on the NASA side. So the familiarity that I have are working with some of their open tile services, like the base map that I showed earlier, and some of the open things like the heat maps. Beyond that, I don't have a ton of experience. But I know they have a vast amount of public APIs available for people to play around with.
I actually listened to you talk about this same topic when there was the closed beta. And I asked you a question about NASA having an extraterrestrial API. I still haven't done anything with it, but I plan to. And I see that you actually included it in your talk. Was that an influence?
I don't think it was planned, but it's definitely fun to see the different APIs, and I know it's even more interesting that Leaflet even supports more than just the normal Earth base map looking stuff, and that you can kind of create things out of this world, which is awesome. But it's definitely neat.
There's a question from Samuel Sandru. Are you familiar with OpenLayers versus Leaflet? Any specific reason why you prefer Leaflet?
So I've definitely heard of OpenLayers. I've heard great things about it. When I started diving into Leaflet, it was due to getting on a new project, which was one of the ones I shared with you. At the time, we were debating whether or not to go with OpenLayers or Leaflet. It was my first time into mapping, but due to the vast experience we already had on the team from Leaflet, we felt that it was the right decision to go with that at the time. That said, I can't really comment on any specific differences between the two, but I have heard good things, and I would imagine there's pros and cons with both solutions.
I'm not sure if you mentioned this. How did you so how did your map career started?
So it was with that the Capella dashboard that I shared during the talk, the satellite UI dashboard. It was my first project, and honestly, I was a little intimidated the first time that I was told about this project, because when I heard about it, I'm like, it's a mapping application. This is going to be crazy hard. Am I going to have to create every single little tile to make that work? But that's what kind of motivated me to create these talks about it, as it's definitely less intimidating once you get into it because of the tools we have available. So that's, and plus you can really build some impactful things with it. So the low overhead of actually getting started with it, plus the things you can do with it, just made me really excited about teaching others about it.
And you have other things, right? So I follow your Twitter, and you frequently share talks and tutorials that you do. Maybe if you could share something from that work.
Sure. So on the side, outside of my day job, I write tutorials, I write introspective pieces, and support that with some YouTube videos. Another talk that I've given was about web fundamentals, which is on my YouTube channel, linked up if you want to take a look. But I really enjoy teaching people about different web development aspects. So through my different tutorials, I've done different things with mapping, which I include a few links about mapping tutorials in my notes that I'll provide soon here, and a bunch of various other things like hosting a static website on AWS S3, or using Postman, which is an API software to test APIs. lot of great things, some kind of intros into different developer tools. Definitely might be able to find something interesting for you.
Is there something that you want to promote then?
Just that
I would...
keep an eye out on my Twitter and Egghead. I'll be giving that. I've been working hard on a workshop where I'll actually walk people through building a mapping application. So I'd love for anybody interested in that to join along. We'll have a fun little project that we'll walk through. So just keep your ears out or eyes and ears open for that, and check out my Twitter and YouTube.
Okay. Thank you for joining us, and thank you for your talk.
Thank you for having me.